Thank you very much. My name is Bruno Daunay, and I'm responsible for the development of the AI technology within the VINCI Group. And I rely on that to the brand dedicated to the development of this technology, which is Axians. You will be able to find them at the end of this the room. Let's talk a little bit about the group. What is the VINCI Group? Maybe you know a little bit what it is. We are a major company, mostly international and very decentralized. We have VINCI Construction that build huge infrastructure like bridges, tunnels, etc. We have VINCI Energies that provides services to the industry. VINCI Concession, where we operate huge infrastructures. So you can see that the group is very diverse. And one of the objectives here is to develop a technology that will be able to help all these different works. We are acting internationally in 120 languages, so that you can imagine that you cannot develop one piece of AI in the central holding of the VINCI Group that will be able to act for the whole VINCI Group. And as well, we are decentralized. It means that we are working with 5,000 different business units, so it's a lot to be achieved. What we are asking nowadays for the technology is to be able to better design, because we used to design. So the first thing that we are asking for a computer is to help us to design, maybe quicker or cheaper. Second thing, we are used to predict, because when you do maintenance or when you act on your daily operations, you usually want to foresee the future so that you take decision at some now, so that you better act in the future. Usually you have lots of sensors in your industry, so what you want to do is to understand these sensors and then take some decision based on these sensors. And last, of course, like every big company, we deal with lots and lots of data, like text data, tabular data. Our objective nowadays is to ask a computer to help us maybe understand a little bit what's inside all these data. So we'll decompose the different use cases that I will show in these all different sections here. But let's talk a little bit about the AI. First, it's not all about the technology. It's first about the people. If you do not understand what the people are doing on their operations, you will miss all the points here. So the major thing that Axians has to do is first understand what everybody is doing within the company, and we are 300,000, so it means we have a lot to do. Second, once you understand a problem, something to be solved, then you will deal a little bit with the data. But of course, if you do not have any data, you will not be able to implement the AI technology. And the little and the easier part is how to find an algorithm to develop your solution. So you can see, when you connect with the people, you don't want to foresee the future, what will be in the future, what we want to do. You just have to ask them, do you have a problem? Do you want to be better optimized? Do you want to earn more money? Do you want to lower your carbon footprint, for example? And once you have this from your operational people, then you can switch to your technology to better do your work. First of all, for example, I know my problem. I know how to design a bridge because it's my job. I've been employed by the company to do that. But there are many ways to build a bridge, for example. There are many ways to build a building. So what we ask for a computer is, which is the best possible solution out of billion solutions? So let's jump to a concrete use case here. For example, in a company, we provide services for the railway infrastructures. So basically, we have 300 technicians that are working on 130 work sites at the same time. And the objective here is to help this technician to do some job, specific job. The problem is that the jobs depend on lots and lots of constraints. The people that you are sending on site, they must know the system. We are in the railway infrastructure, so it's all about security. So they have to understand the train that will have to drive on the system. You have to know the industry you are working on, the client as well. You have to be qualified to do your operations. You have, of course, HR constraints to satisfy. You must not work more than 10 hours a day. If you work at night, it's not more than 8 hours and 30 minutes, something like that. So you can see that it's a lot of constraints to deal with in order to optimize your scheduling every day. And for that, we have a team of 20 people. They are every day trying to find the best schedule for all our employees to be at the right moment, at the right time, doing their job. So Axians helped us here to develop a solution that lower the pressure on the team. And quite easily nowadays, every morning, all our employees have their schedule when they have to face an operation on site. So we scaled this in New Zealand for the oil and gas industry, for example. We scaled this in Austria and Germany, which is more for the service to the industry. And in Paris, it's more for optical fiber maintenance, for example. Second use case, it's all about design. We are used to implement cables. We are used to implement fire extinguishing systems everywhere. And you can look at the ceiling here. You can see the red pipes. These are pipes dedicating to fire extinguishing system. But the system that has been implemented here, is it the one and only solution, the best one that lowers the cost? Is it the one that has the lowest impact on the environment? Is it the one that has been decided because we spend less time to build all this network here? I'm not sure. So what we are doing here is just to put a lot of constraints inside our reinforcement learning algorithm so that it provides the one and only solution that is the best, for example, about the cost. We want the best solution that costs the less. We want the best solution that has the lowest impact on the environment, for example, etc., etc. Or you want the solution to spend less time on your operation and to install all the system. Once you design this system here, the fire extinguishing system, you can quite easily see that we can as well arrange the cables. We can easily design all the pipes that you have on the ceiling, the HVAC system. So all the things that are designed nowadays inside a building or inside an industry, you can put it in an AI algorithm. The beauty of it is that you do not need lots of data, you just need competencies, you just need a regulation that tells you what you have to do, what you do not have to do, and then you have the best solution out of what you want. So this is implemented for the industry. It's exactly the same for the construction industry, for example. We have to build this building here, and the case that we have to deal with, should we dig 3 foundations, 4 foundations, 5 foundations? What is the thickness of the layer to support this building here? That is the kind of question we have every day. And we use this huge machine here to reinforce the earth, for example. The question that we have nowadays, of course, we know how to do that because we've been dealing with buildings and railway infrastructure since a long period of time. But we did it the traditional way. So we have design offices. We spend 1 week, 2 weeks, 3 weeks to design these systems here. What if we could lower the amount of time spent to design this infrastructure? That is a question that we had at that moment. So here we design, again, using reinforcement learning, a solution that quite quickly find the best solution out of billions of possibilities. The good thing is that once we have the solution, we can go and see our client, telling them we have this solution, and then the client changes his mind, telling us, yes, OK, it's the best solution because it's the cheapest. But now I change my mind. I want a solution that lower the impact on the environment. In a matter of 10 minutes, you are able to provide your client with a solution. And then again, he changes his mind because the client changes his mind all the time, and he wants a solution where you spend the least time on the construction site. So here again, you can provide a solution, and this technology here will maybe try to standardize a little bit the solution. Maybe it will standardize the hole that you have to dig. It will standardize the concrete that you have to pour in the foundations. It will standardize a little bit maybe the steel that you put in the foundations. So here, we do not change the way of doing things. We just optimize our designs. And we are quicker in a way in the implementations. This was more about having the best solution out of a billion of solutions. Then we switch to another technology because we want to make sure we do not have any problem. So you have to understand when a problem will occur. So here we are more in the prediction technology. An example here, we operate this offshore windmill here. The problem is that when this huge infrastructure have a problem, you will have to rent this huge boat. This boat has to go at sea, and when the failure occurs, you have a big crane that has 300 meters high, and you have to lift a 5-ton generator. So it's a very complex system, and you do not have much of these boats. Usually, we are hundreds of clients using the same boat. The problem that you have here is that you know that it will fail. When it fails, you lack green energy production, and that we do not want. So what we have to do here is to predict long time in advance where the problem will occur, so that we can rent the boat long time in advance. And once the problem occurs, the boat is at the right place at the right moment, and we can change the generator, and we do not lose too much green energy production. So this has been scaled in Germany, in the offshore wind farm north of Germany. And in France, here, it's quite easy. We build and we operate nowadays a railway between Paris and Bordeaux. We know how to operate this. Of course, we've been doing this since hundreds of years. But we are doing this the traditional way. It means that we are performing maintenance every day because we feel like it's the way to operate. What if we use data just to understand whether you have to do the maintenance at the first kilometers, the 100 kilometers, or the 200 kilometers? Using here a Bayesian model, you can put a little bit of human interaction in the loop so that you do not completely rely on the data. And it's a balance between the experience of the people and then what information is given by the data here. Using this system here, we lowered by 20% the maintenance, so it's about €1 million saving per month. And because it's a contract for 40 years, you can imagine the huge saving here that we have. When it comes to operate building, one of the examples here is to predict the temperature inside a room or inside this room, for example, so that you can act quite quickly on the HVAC system. All the buildings like this one, they have a system where you can act on the temperature, the air that is blown, etc., etc. If you can predict just a minute or 10 minutes or 30 minutes in advance what will be the temperature depending on the condition that we have here, the number of people in the room, the people that are leaving the room, the people that are entering the room, etc., then you can act quite quickly on the system, and by doing so, you save huge amount of energy. You do not blow the air for, I don't know, 2 hours, because you do not need this. You just blow the amount of air that is needed for the temperature to be the one you decided. By doing so, again, you quite quickly have savings in your building. So when you operate this kind of building, usually it's between 25% saving during the winter and 20% saving during the summer. So it's a balance between the air conditioning and the heating, of course. Third, technology. You cannot be everywhere. You have to maintain huge infrastructures, like 30 kilometers high-speed railway, for example. And you want to see your problem. What are the problems in my huge infrastructure here? One of the technology we use, for example, it has been developed by Cyclope AI, which is a company that we created inside VINCI. The objective here is to detect all the different vehicles at a toll gate to quite quickly decide what is the price this vehicle has to pay. So here it's all a matter of detecting what is happening in the toll gates and then classify quite quickly the prices. Of course, it has been until now achieved by a human, but here, by developing a model here, we achieve 99% accuracy. So we are a little bit better than a human, and we lowered by 700,000 the amount of problem that we had at the toll gate. So it results in a car driving quite easily in the toll gate, because the future will be toll gate without any barrier in it. So we are preparing the future where you will have only to drive on the high-speed railway, high-speed highway, and you will pay at the end without any barrier in the highway. So this is all about using computer vision to detect elements inside a picture. Smart retail have been developed here by Axians at scale in Portugal and in France. The objective here is to understand the behavior of our customer inside a shop, for example, so that you try to optimize the layout of the shop. The objective here is to maximize, of course, the amount of elements paid by your customer. What you want to do here is to understand the displacement of the people inside the shop. You want to understand if they took a component, what is the next component they did, so that you can assemble in the right place at the right moment. Of course, one of the tricky things is to be AI Act compliant, and of course to be GDPR compliant here. So that's why Axians has this certification here. And if you want to develop something with someone that is really trustable, use Axians, because they are very sharp on this. Last, technology. There are too many documents, and unfortunately, you do not have enough time to do what you want to do. So what should I focus on in that, in all this amount of data? We are more on the LLM part here. So what could we do, and what have we scaled within the organization using this technology? You all know this use case here. You have lots and lots of tenders that are produced every day, and you do not have the time to price all these tenders. For example, this one have been developed using VINCI Construction. They specify on the road, for example. So each day, we deal with 20,000 tenders that are published. It's impossible, honestly, with the amount of people we have in the company to price everything and to target the tender where we want to go. So we develop here a system that really understands the tenders, and so it provides a resume to the operation so that they have a glimpse of what the client wants to do. And of course, because we have a lot of data concerning previous tenders, we can provide an estimation of what could be this tender and at what price they could answer. By the way, if you combine this with a prediction system, then you can understand who will answer this tender and what would be the price of your competitors. And then you can decide whether you apply the price that is given by your algorithm, or you decide to lower a little bit the price according to what you know on your operations. So here, it has been scaled in France. We have nowadays more than 550 users, so it's working well, and we are trying to extend this in the other country we are operating on. It's in terms of price, we priced until now €1 billion tenders. It doesn't mean that we get all the tenders, but we priced them, and we were able to tell our operations that a lot of tenders could be answered. Last, you all know nowadays this kind of software, but this one has the particularity to have been designed to be scaled right at the beginning. The objective here is to lower the amount of time spent on reading contracts or reading tenders. The problem for our lawyers is that it's not to provide an answer to our operation. They know their work, they know the risk, they know how to detect risks inside a contract. So this is not where we want to jump. But the problem is, if you want to conclude on a contract, you will have to read the contract. And when you have thousands of pages of contract, then you will spend a week, basically. What we want to do is reduce this amount of time spent on the documentation and just show the lawyer the part where they have to base their decision. So by doing so, we scale this internationally. It's a specific company here. It's VINCI Construction, but it's called Soletange Fraissinet. It's a very decentralized organization. And we scale this in 12 countries nowadays. So different language. We have Polish, we have Turkish, we have Indonesian, we have English, of course, Portuguese, and Spanish. They are all acting on the same software. And the good thing is that it has been developed using all the lawyers within this organization, hundreds of them. So now they are doing this job more quickly. So I would say, before you start coding and building expensive infrastructure, because it's really expensive, do you have a problem? That is where we start all our development. Do you have any problem to solve? Thank you very much.